Good morning. Today we are going to see about a topic called design patterns, and in design patterns we are going to see distinctions between abstract factory and factory pattern. So let's see an overview of design patterns. So introduction to design patterns. Design patterns are proven solutions to recurring design problems in software engineering. They promote code reusability, maintainability, and scalability. Today, we will focus on two key creational design patterns. One is abstract factory and the other is factory pattern. These patterns play a vital role in object creation and instantiation within a software systems. Importance of design patterns. So let us understand what is design patterns are. Design patterns are categorized into three main types: creational, structural, and behavioral. Creational patterns deal with object creation mechanisms and provide flexibility in object creation. Abstract factory and factory pattern fall under this category, aiming to solve problems related to object creation and instantiation. So now, how to create a design patterns? First we will see about creational design patterns. So creational patterns focus on how objects are created. They abstract the instantiation process and make a system independent of how its objects are created, composed, and represented. Abstract factory and factory pattern are commonly used creational pattern, each with its unique characteristics and use cases. So let's see about factory pattern. We will explore some points on factory pattern. So the factory pattern, a creational design pattern that provides a structured approach to object creation. The factory pattern serves as an intermediary between client code and the concrete implementation of objects. It encapsulates the object creation logic within a separate factory class and delegates the responsibility of object instantiation to subclasses. So the main key characteristics of factory pattern include interface for object creation. So what does it deals with? The factory pattern defines an interface or a base class for creating objects. This interface typically contains one or more factory methods responsible for creating instances of different concrete classes. Second, flexibility to subclasses. So here, subclasses of the factory class implement the factory methods, each providing its own implementation on creating specific type of objects. This allows for flexibility in creating different types of objects without modifying the client code. And third, loose coupling. By encapsulating object creation logic within the factory class, the factory pattern promotes loose coupling between the client code and concrete implementation of objects. The client code relies only on the factory interface, remaining unaware of the specific class being instantiated. So now let's see about some points on abstract factory. So overview of abstract factory pattern. The abstract factory pattern is also actually another creational design pattern that facilitates the creation of families of related or dependent objects. Unlike the factory pattern, which deals with creating individual objects, the abstract factory pattern is designed to address scenarios where multiple related objects need to be created together. So we'll see some key characteristics of abstract factory pattern. The first one, the interface for object families. The abstract factory pattern defines an abstract interface for a base class for creating families of related objects. Whereas in factory, there is no thing like dependent or interdependent, independent. So this interface typically includes a set of factory methods, each responsible for creating a specific type of object within the family. Second, decoupling client and concrete implementations. By providing an abstract interface for creating objects, the abstract factory pattern decouples the client code from the concrete implementation of objects. The client interacts with the factory interface without needing to know specific type of objects being created. Third, flexibility and extensibility. The abstract pattern enhances the object flexibility and extensibility by allowing the system to support multiple families of related objects. New families of objects can be added to a system by implementing additional concrete factory classes without requiring modifications to the existing client code. So this type of codes can be used for reuse. So mainly those who are working on a similar projects, they can reuse the existing code from previous projects, and they can utilize it in a new thing. So this improves the maintenance, and it will reduce the cost of creating a new thing. So here we will see the structure and components of abstract factory pattern. So the first one, we have abstract factory interface, where this interface of base class that defines the factory methods for creating families of related objects. Next, we have concrete factory classes, concrete implementations of the abstract factory interface, which are each responsible for creating a specific family of related objects. And third, product interfaces. So these are within each family it is present, and concrete product classes. We have concrete implementations of the product interfaces representing the specific type of objects within each family. So now let's see about some differentiation between this thing. So okay. So the comparing abstract factory and factory pattern. So when comparing the abstract factory pattern and factory pattern, there are several key distinctions to consider. So while the abstract factory pattern creates families of related objects, the factory pattern focuses on the creation of individual objects. So the intent of abstract factory pattern is, if it focuses on creating families of related or dependent objects. It provides an interface for creating multiple related objects without specifying the concrete classes. So the intent of factory pattern is it deals with the creating individual objects, right? So the provides an interface for creating objects, allowing subclasses to alter the type of objects it's created. So what is the scope of these patterns? The scope of abstract factory pattern is it has a broader scope as it creates families of related objects. It is suitable for scenarios where multiple interrelated objects needs to be created together. Whereas in factory pattern, it has a narrower scope as it deals with creating individual objects. It is suitable for scenarios where only one type of object needs to be created at a time. Multiple instances are neglected in this pattern, factory pattern. So when it comes to complexity, uh, we abstract factory pattern can be more complex when compared to factory pattern, because it focuses on creating families of objects and managing multiple factories, whereas in factory pattern it is only one factory is considered and easy to maintain. So it requires careful consideration of the relationships between objects within the family. In factory pattern, it's generally simpler when compared to abstract factory pattern, as it deals with creating individual objects. It involves less overhead and is easier to implement and understand. So the for example, when we consider an example for this thing, we can say abstract factory pattern is for creating GUI components for different operating systems, where each of family of objects consider buttons, text fields, and etc. is specific to the operating system. In factory pattern, factory pattern, we can take an example of creating a different type of vehicles, where cars, bicycles, motorcycles, where each factory method creates a single type of vehicle. So when to use these patterns, when to select and how to select the patterns according to the scenario. So it's pretty simple that abstract factory pattern can be used when the system needs to support multiple families of related objects, and the client code should be independent of the specific classes of objects being created. So factory pattern can be used when the system only needs to create individual objects. There is no requirement of managing families of related objects. Simple. If there are more families or involved in that scenario, we can go for abstract factory. So when there is only one scenario is given in the scenario or question, we can select factory pattern. So let's see some more examples of real world examples of the patterns. For example, we can take a manufacturing process where in for abstract factory pattern in manufacturing process such as automobile production where different models of vehicles are produced like sedans, SUVs and trucks need to be assembled within the parts from different suppliers. So an abstract factory interface can define methods for creating vehicle components such as engine, chassis, wheels with concrete factory implementations for each vehicle model, right? Whereas when we come to factory pattern, same examples can be discussed here, like in food production facilities where different types of packaging, bottles, can, pouches needs to be filled with various products, soft drinks, juices, and sauces. Factory methods can configure appropriate filling machines based on the product and packaging type. So when we come to next year, let's take another example of abstract factory pattern, wherein we'll take e-commerce platform. So in e-commerce platform, let's take where an in like it has a different payment gateways, right? So like PayPal, Stripe, and Square, Paytm, GPay, PhonePe, some etc. And this needs to be supported for processing online transactions. An abstract factory interface can define methods for creating payment processor objects with concrete factory implementations for each payment gateway. Whereas when it comes to factory pattern in same platform we're going to take, it's any in-commerce in a product catalog system where different types of products like electronics, clothing, books needs to be added to the inventory. So factory methods can create instances of project based on the category or type selected by the users. Right. So the factory pattern is commonly used when you want to delegate the responsibility of object creation to a separate class or method. It is suitable when the objects to be created do not vary based on a specific context or conditions. Some use cases of factory pattern include creating different types of vehicles, generating different type of file readers or writers, or instantiating different types of database connectors based on configuration, which we saw earlier. And when it comes to use case of abstract factory pattern, it is commonly used in situations where the system needs to be independent of the way objects are created, composed, and represented. It is suitable for applications that require families of related objects to be created and used together. Some examples we already seen earlier. Again, I'm repeating, and it's included creating different types of UI components, which we saw, generating reports in multiple formats, or supporting multiple database types in an application. So yeah, so when we have come to reach the last part of our thing. So it's always a conclusion and takeaways. So in conclusion, abstract factory and factory pattern are powerful tools in software design, offering solutions to common object creation challenges. So we have understood their principles and differences. So software engineers can make informed decisions when designing software systems. So while both these patterns are used for object creations, right? They have some distinct differences, which allows the creation of families of related objects where it's actually used in abstract factory, while the factory pattern focuses on creating a single object. These are main differences between these both. So if you understand this, it's pretty easy to differentiate, and you can apply these patterns in your scenarios. So, so I encourage you to explore these patterns further and apply them judicially in your projects to achieve scalable, maintainable, and efficient software solutions. So that's it for today's class, and thank you.